Hello class, today we're going over lesson 5.4, how to solve inequalities using addition or subtraction. So what is an inequality? Well, an inequality is similar to an equation where we have two expressions on each side, except now they're separated by either a greater than, a less than, a greater than or equal, or a less than or equal sign. So they'll look like this: a greater than sign, a less than sign, greater than or equal to, or less than or equal to. Hopefully we're familiar with those. We should have seen them a couple times by now. So this tells us that one side of the equation is either larger, smaller, or the same size as the other side of the equation. All right, so for example, with using these signs here, we can see all right, so using these signs here, we can see something like 3 is less than 5, or 5 is greater than 3. We can also see something like 5 is less than or equal to 10, right? And in this case, 5 is less than 10, right? It's not equal to, but 5 is less than 10. But if we said, for example, 10 is less than or equal to 10, this would also be true because 10 is equal to 10. Okay. All right, so our key focus for today is we're going to be solving inequalities with addition or subtraction. It's the same as when we solve equations, where you use the inverse operation to cancel out terms and isolate the variable. So it's the same thing as we've been doing in the past, except now, instead of it being separated by equal signs, it's being separated by a less than, a greater than, a less than, an equal to, or a greater than or equal to sign. So let's get into our first example here. We want to solve and then finally graph the solution. All right, so solve and then graph the solution. X plus 5 is less than 7. All right, so I'm still going to draw my line straight down here because it helps me out. And then how do we get rid of this 5 on the left? Well, the same way as when we're dealing with equations, we're going to subtract a 5 from both sides here. So 5 minus 5 is obviously 0. So on the left, I have an x. Now we're going to bring down this less than sign here. That doesn't change at all. So x is less than, and 7 minus 5 would be 2. So x is less than 2. All right, let's try to graph this equation. So I'll put a 0 here, a 1, 2, 3, -1, -2, -3. All right, so since x is less than 2, now it's not less than or equal to, so we're going to use an open dot here. The reason we're using an open dot is to show that 2 is not included in the solution. Because remember, x is less than 2. X is not equal to 2. And then we can draw a line here pointing to the left to show that all of these numbers right here, everything this line is above, are solutions to this problem. Now let's think about that. We could plug anything in here. Let's plug in 0. So 0 plus 5 is equal to 5, and 5 is less than 7. All right, what if we plug in -2? Well, -2 plus 5 is equal to 3, and 3 is less than 7. So for every single number we plug in here that is to the left of that 2, but not including 2 itself, then those will be solutions to this problem. Okay, x plus 7 is greater than 12. So let's solve through this one here. Again, we're going to draw a line straight down from our greater than sign, and we're going to try to isolate our variable here. So we can subtract a 7 from both sides. 7 minus 7 is 0, so on the left we have an x. And on the right, 12 minus 7 is 5, so we have an x is greater than 5. Now to graph this solution, again, similar to last time, we have a 0, 1, 2, 3, 4, 5, 6, -1, -2, and so on and so forth. So again, it's not greater than or equal to, it's just greater than, so we don't want to include our 5, and then it's going to be everything to the right, since it is greater than, everything to the right of 5. All right, and then we can plug in here to check. Let's just check with a 6 here. 7 plus 6 is equal to 13, and 13 is indeed greater than 12. All right, we got another one here. X plus 10 is greater than 14. All right, start off by drawing our line down. We could subtract a 10, and then x is greater than 14 minus 10 will give us 4. Okay, so we'll have a 0, 2, 4, 6, and everything to the right there. Now, still greater than, so we're going to keep that dot open. And then since it's pointing to the right here, it's a greater than sign, we're going to do everything to the right of our equation here. All right, now let's go into a word problem for this one here. So the maximum number of students allowed in a classroom is 26. If there are 16 students lined up outside of class, how many more can be allowed in before the classroom is full? All right, so we have 26 students in class, so this is going to have to be less than 26 here, so I'm going to put the greater than sign pointing to our 26. And then we have a 16 plus x. So our 16 plus x has to be less than 26. You could also write this as 16 plus x is less than 26. All right, so let's solve through here. I'll solve through the one here on the left. Again, we need to isolate our variable by subtracting a 16 from both sides. And we get 26 minus 16 will give us 10. So we've got x is greater than, or sorry, x is less than 10. But let's think about this. Does x simply have to be less than 10, or can x be equal than 10? Well, since 26 students are allowed in the classroom, this should be a less than or equal to sign. So x will be less than or equal to 10. And let's think about that. If we plug in 10 for x, so 16 plus 10, that'll be equal to 26. And 26 is equal to 26. So we know that we have the maximum amount of students in the classroom, and we are okay with that. All right, let's go over what we talked about today. Today we were talking about inequalities, which are practically the same as an as an equation, except now we are separated by a greater than, less than, greater than or equal to, or less than or equal to sign. And we learned about graphing inequalities. Remember, when it is a greater than or less than sign, we use an open dot. And when it is a greater than or equal to, or less than or equal to, we use a closed dot when we're graphing. And that shows that we use that number there. Alrighty, class, I will see you all in class on Monday. Hopefully this will help you out on these questions with our homework assignment. Good luck to you all, and bye-bye.